circular fertilizers. They can be also called bio-based fertilizers or alternative fertilizer. They are based on recycled, nutrient-rich streams of organic materials, so they contribute to sustainable bioeconomy in Europe. They also are very good at displacing GHG emissions in general, because you can replace mineral fertilizers used with circular fertilizers.
Most of the circular fertilizer we are analyzing are organic fertilizer, which add organic matter to the soil. And organic matter in soil is one of the most bigger carbon pool that has an amount of carbon which is more or less the same as fossil fuels. In the last century and a half, the amount of carbon that was released from soil change use is 1/7 to the carbon released with fossil fuel consumed. And as you may see, adding carbon to the soil, which is a carbon that can stay there for a long time, even centuries, could be a possibility to reduce climate change.
Conventional fertilizers, more specifically mineral fertilizers, often release high amounts of nutrients quickly into the soil. Not all crops can use all of these nutrients immediately, so the rest can leach into the environment. We have a lot of different circular fertilizers, including also slow-release nutrient fertilizers. So when used correctly, the uptake of these circular fertilizers can align better with the uptake need of the crop. So there are less nutrients left to leach into the environment. You need to pick the right fertilizer for the crop at the right moment to minimize the nutrient leaching.
All the phosphorus we need in Europe, actually we have to import it. It comes in as phosphate rock, supplied for fertilizer production or as feed for our cattle. In the best case it ends up in wastewater, then it's transformed into a waste but the phosphate is lost, we can no longer reuse it, or it goes immediately into the environment where it can cause us problems such as eutrophication. Struve technology picks in on that, so there we can also take out the phosphate from a liquid stream, either wastewater and sludge, and produce immediately a product that can be either used directly as a fertilizer or as a resource to make a mixture of fertilizers. Nitrogen we take out of the air with the Haber-Bosch process. It's a very energy-intensive process. If it then ends up in the wastewater, we need additional energy to nitrify it, to put it back into the air. We lose carbon source, which we would like to use to produce biogas. And there is a high risk for NO2 emission, so a potent greenhouse gas emission. The thing is, if you recover nitrogen and you can take it as ammonia, as the reactive form, you omit the green gas problem, and you can also then immediately reduce it as an energy carrier to process further, again to a fertilizer or for fuel cells and so on.
Organic matter also brings a lot of good effects on soil and on agriculture. For example, it can retain water and increase the availability of water to plants during the dry season, and while in the same time during heavy rains can avoid an anoxic situation for roots. And also organic matter in soil acts like a sponge, because it is soft and so makes soil easier to till and also easier for roots to growing in, and they can grow healthier and deeper. Organic matter can retain also and absorb nutrients, so reducing the amount of nutrients lost and increasing their efficiency.